Hi and welcome. This time around we have another project for the Char's DBit grinder. It's one that I've been looking to do for a while now and one that other YouTubers have contributed in the past. In short, the wheel holder that comes with the Char's DBit grinder, normally it comes with just one, and so to replace the wheel you just remove this outer hold down plate, pop the wheel off, pop a new one on and tighten it down and you're good to go. There is a locking mechanism back here under this bolt here. You can stick a pin through and it locks the spindle down. However, you can buy more of these holders similar to a surface grinder, and you can replace them. And what holds it in place is this single Allen screw and a tapered shaft. Popping it off the tapered shaft is not all that simple. So once you unscrew this cover screw off of here, you can just sit something like this Allen wrench in there and it locks the spindle in place, so you can remove that screw on the end here. Once you get the screw off, it's still not coming off because it's been pressed onto the tapered shaft, and that's kind of a trick. So we're going to make a tool to allow me to exchange wheels, arbor and all, or not arbor and all, but wheel holder and all, just like a surface grinder, so you can have multiple wheels preset. Also, these inexpensive Chinese wheels are not particularly well balanced, so at some point I want to make an arbor to hold these wheels so that I can turn them on the lathe. For now, we're just going to make a tool to make it easy to remove the wheel with the wheel holder and all. So what you'll notice with the spare wheel holders, there's some additional threads in here that don't seem to play any obvious use in its retention, which it's not, because this bolt goes through and pulls this guy onto the tapered spindle. However, it does serve a use in that you can screw in a bolt here to push this guy right off the end of the spindle. Now, you can just use a bolt all by itself to push it off the spindle, but wouldn't it be nice to have an all-in-one tool that would both remove this and be able to pop this guy off the spindle? So we're going to take this M8 bolt here, use those pre-done threads, which match the threads inside the abrasive holder, and we're going to make an adapter that will push in a pin. So this is smaller in diameter than this M4 or 5 bolt here, and so it will go to the bottom, so I can tighten on these outside threads and push this guy right off the spindle all in one go. And we might as well make it a nice convenient form factor, because historically to change a wheel, every time I would take this tool, pop the wheel off, put a new one on, except that's not including any balancing, which isn't a huge deal, but if you get some of these really inexpensive wheels, they aren't terribly well balanced, and so there's some additional vibration that you probably want to address. So I found a scrap piece of 1/2 inch 303 stainless, and we'll start with that to be the body of this tool. In one end, we're going to thread this guy and Loctite it in place, and then leave enough threads that we can screw into the end of one of these guys. But then we're going to hollow it out and put this bar down the center of it, or a smaller one. This is like 3/16. We might want just 1/8. That'd probably be plenty, because all that bar's job is to push. When the threads are tightening down, it pushes on the arbor itself and pulls the whole abrasive holder off. And then the other side, we want to drill and tap, not drill, and press fit an Allen wrench in. So I've got this spare Allen wrench that's the right size. We're going to cut it off with an abrasive wheel. So another thing that pops up is when you're trying to remove the cap head screw that holds this carrier in place, is that the one that comes with it barely reaches past the edge of the tool and the guard, so it's very hard to tight. We want something that sticks out a little further to make it easier, so you don't have to really dig and get your hands in there and ding your knuckles when it breaks loose. So let's get started on this pretty straightforward project. First up, I want to take the end off the Allen wrench here, and so I just have a straight shaft. Really handy tool is this DeWalt cordless angle grinder. I use this thing all over the place, mostly as a cutoff wheel. It is sure handy. Goes through hard materials like butter. Now that I've cut the ends off this guy, I'm going to measure across the points here, and I will come with a drill bit that is, I don't know, 10 thousandths under, and we'll just press this guy in. So this is 0.225, 0.22, 0.223. Okay, So we're going to go something like 0.215 or something in that area so we can press fit that in the end of this guy. This is just some scrap stainless I had around, which why not? Stainless is pretty. Next up, we're going to drill a number 4 size drill. It's about 10 thousandths undersize. Just to make it look pretty, we're going to put a taper in the end. Fortunately, this is easy machining and probably should have slowed that down a little bit, but that looks pretty good. And the Allen key is it's not even a easy press fit at this time, but since it's only going to make contacts in the 6 corners, it should just basically broach itself a path down in there. Flip it over, we're going to drill and tap this side for M8 course, but first we're going to face it off. Got a tap drill. The closest US drill bit is an H. It also, in metric, it would be 6.8 millimeter. I don't have one of those. My metric drill bit set goes by 0.5 millimeter increments. I have a set that's by 10th millimeter increments, but unfortunately, that only goes up to 5.9, so I don't have a 6.8 millimeter. Now we're just going to hand tap this guy. I have a spiral flute tap in here, so it'll eject chips to the back instead of a spiral tip tap, which would push chips forward. I could get away with either because I made this hole extra deep, so it would have worked fine either way. But we also have a spring-loaded follower to keep this guy centered so you don't go off at an angle. Strangely enough, you can tap at an angle, and you'll have deeper threads on one side and shallower threads on the other side. How do I know? I've done it before. Got some permanent Loctite here. I'm just going to thread this guy right on in. We're going to bottom it out, and then we're going to tighten it up. There we go. Boy, that'll be perfect amount of thread sticking out. A lot more inside than I needed, but I guess it's not going anywhere. All right, so I'm going to part the end of this bolt off, leave a little bit extra so I can clean some stuff up. I think I can go faster than that. Oh, and we can get rid of the excess Loctite there. That's not necessary. Seems like my cutter is not on center. I'm going to check that real quick. I might need a center in the end of this guy. We might do that because it's wobbling all over the place, and that's probably part of the problem because it's unsupported. Although you don't normally part with a center, but All right, let's see how it parts now. I mean, you really shouldn't part with the center, I think. I've thought about this one before. I've never come to a complete conclusion. That was my cutter. These are really inexpensive Chinese cutters, and I think that they dull pretty quickly. I've manually sharpened them on the DBit grinder before. Yeah, look at that. It's just broke the bit off and wedged it in there. Let me replace it and be right back. Got a brand new sharp cutter now, and I have my longitudinal feed locked. I might have bent this screw though, which is not good. I could prevent it from getting wedged by just coming over and removing a little more material over here. That's cutting a lot better. I think the other cutter was dull. Okay, let's remove support. There we go. That worked pretty well. Very nice. Now we will, well, as long as I'm at it, I want to chamfer here just to make it look better as well. I'm going to start with the center drill. Then we're going to go an undersized drill bit for 3/16, and then we're going to ream it. Be a great place for a stubby drill bit. Now we're going to ream it undersized. I'm taking off a 1/64 of an inch of material. So I test fitted this guy on the grinding wheel holder, and this diameter is slightly larger than this, probably because it's metric, and this is metric and this is 1/2 inch. So I need to take off a little bit of material there so that we can get clearance so that I can screw this down. Either that or I would have to leave more thread sticking out, but I thought that would make it vulnerable, so I didn't do that. So we're going to take some thread, we're going to take some material off here. So let's try a test fit now. There you go, perfect. Now that clears, excellent. All right, before I press fit in either parts that go in either end, we need to take it over and cross drill and tap for a set screw for the handle that is going to let us twist this guy. Give us a little torque advantage. I just found the center between the vice jaws. I've got my ultra thin parallels here that this is sitting on, because 1/8 inch parallels would get hit by the drill bit. So, because we're drilling 3/16. So, well, it may not, but it was too close to for my comfort, so I went with the smaller parallels. All right, so we're drill and tap for 632. This is a cross hole. Probably could be higher RPM for such a small drill bit size. Just going to tap. This is a very tiny trap drill, 632, so I'm just using the quill to line it up. And it doesn't take a lot of torque, so and that's it. All right, so I have to press in parts in both sides of this tool, and in order to do that, I've got a little bit of a challenge in my hand, because when you push in one side, then the other side's going to be challenging to press in. So what I'm going to do is, since the hex side is probably going to take the most force to push in, I'm going to thread this guy into one of the grinding wheel holders, and that'll support the base, hopefully adequately. And then I've rounded this off a little bit to get it to start. And we're just going to press it in gently. I need 2 hands for this, so give me a sec. All right, so we're going to press this in slowly on the 20-ton press. Oh, not good. All right, so the press wasn't cutting it because it was shifting side to side too easily. So instead, I took my brass hammer, put this guy threaded in there, and just tapped it, hammered it in place. And it worked actually pretty well. So now we just got to put this pin in this side and get the length right. Now, the length is kind of a trick. What I did was I took some smaller diameter material that just fit in there freely and played with that until I think I got what is good ejection length. And this is a little longer than that, so it'll eject sooner. But that means it may not have captured enough threads, so we'll play with it. I can always make it shorter, just can't make it longer. So let's get this guy in there next. All right, so I tapped this guy in as well, because pressing it in was proving to be very challenging, even though that's just a 1/2,000th undersize interference fit. But it was still surprisingly tight. So now we got to check the length. So we're going to go over and test it. And I'll put the crossbar in first here. And you see I put a little notch in it to catch the set screw. Actually, it's more than a little. I got a little aggressive on the grinder, but I think it'll still be plenty strong. If not, I'll make another one. All right, so here's the completed tool. Allen wrench on one side and ejection pin on the other side with threaded section. So let's give it a test, see if it works. All righty, comes time to swap out the wheel. Pop in the Allen side. Trying to do this one-handed while holding the camera with the other hand, so it's a little awkward here. I don't have a tripod for this portion of the shop. Now normally if I was doing it, I'd just be spinning the handle myself. You know, you could have just been spinning this guy on the end like this, but it's hard to do one-handed. So anyways, now you pop the other end with the pin that goes down the hole where the screw just was, and you tighten this guy in and pop. Now we're free. That's it. Pretty handy tool. If you're going to use multiple abrasive wheel holders, then I highly recommend this. Otherwise, you don't need it, because on the rare occasion when you have to swap the belt out, you can just use a normal you can use a hammer to pop this guy out. You just gently tap around the edge here, which is what I had to do, by the way, to get this guy off. So anyways, that's pretty much it. Pretty cool tool. The idea was originally Tom Lipton's, I believe, but Robin Renzetti also has done it. So those are 2 guys definitely to follow, because they are excellent machinists and share their knowledge, which we all really appreciate. Thanks for watching. Hope you find it useful. Hope to see you next time.